Hello everyone, my name is Aditya. So in this video, we'll see how to interface an IR obstacle sensor with Arduino. So this particular IR obstacle sensor has both digital output as well as analog output. So if you are using this on a broad daylight, then I recommend you to use a digital output because the daylight also contains an infrared radiation, so it may affect the analog readings. So I recommend you to use a digital output if you are using on broad daylight. So let's get started. This is an infrared obstacle sensor. So it consists of an IR transmitter and IR receiver. So it works by transmitting an IR signal from IR transmitter, and then if there is an object in front of it, the IR signal is reflected from the object and is received by IR receiver. If there is no object, then the transmitted signal is not reflected and hence the IR receiver does not receive any signal. So it consists of input of 5 volt and ground for the sensor, and it can give both digital output as well as analog output. And there is also provision to calibrate the sensor to adjust the sensitivity. Let's see the connections. So plug the IR sensor into the breadboard, then connect 5 volt to 5 volt of Arduino, and then connect the ground to the ground, and then connect the digital output pin to the any of the digital pins. I will connect it to pin number 8. So let's see the programming part. So the programming part is quite simple. So we have connected D out to pin number 8. So I have defined pin number 8 as an input pin. Then I have written serial.begin. It begins serial communication with 9600 baud rate. Then inside void loop, I'm just printing it serial.println the value which is received on digital pin number 8. So using digital read of pin number 8. Then I have given a delay of 1000. So that means every 1000 millisecond, that means 1 second, it samples the signals and then it displays on the serial monitor. You can also change it. You can give 500 millisecond if needed. So just compile this and then we'll upload this, and then we'll open a serial monitor. You can open it on the screen. You can see a serial monitor on the top right corner. Just open this and you can see the signal being displayed. As of now it is 0 because there is no obstacle detected. So once I bring my hand top of it, you can see that 1 is being displayed, and then when I take out the hand, it is back to 0. So let's see how to control an LED with the setup. So I've defined pin number 7 as an output pin, and then I've increased the sampling rate. Now every 25 milliseconds it samples, and then I've defined an LED variable as 0, and when it receives a 1, then it goes inside the if, and the LED will toggle itself. That means 0 becomes 1 and then 1 becomes 0, and then digital write of 7 comma LED will make the pin number 7 according to the LED status, LED variable status. That means 0 means it will turn off the LED, and then 1 means it will on the LED. So that means whenever it receives a 1, it will toggle the LED pin, LED variable, thereby toggling the pin number 7 with on and off. And then I have introduced a delay here. So this is the simplest debounce. So because it needs to differentiate between the simultaneous presses, so we have 1000 millisecond, that means 1 second delay. So we can control the LED for every 1 second. So the threshold is 1 second. Okay, so now let's try to upload the sketch onto our board, and then once it's uploaded, you can see whenever I bring my hand close to this sensor, so the LED glows. Whenever I bring again, the LED turns off. So this is an infrared sensor, so it has an infrared receiver, so we can also extend this by taking any infrared enabled device, which is the simplest remote. So you can take any remote and then you can try to control the LED, because even this emits an infrared signal, and then if that is received by the receiver, then the LED glows. So let's try it. Let's press a button. You can see that the LED glows. So to turn off, just press button, then the LED turns off. So you can use any buttons, because we have not programmed for each button. So whenever it sees an high on the digital output, so the LED glows. So what we can do is we can also decode these buttons, and then we can control multiple LEDs with each button. So right now I have not set the decode, so that whenever it sees one, it will turn on the LED. Okay, so that's it for the tutorial. Hope you enjoyed it, and we'll see next time. Thank you.